I know it is, but at some point they'll turn the mic on. Yeah, good. So if I could encourage you to take your seats, please. So good morning, ladies and gentlemen. My name is David Kelsey. I have the privilege of being the chair of the program committee for this conference, and as such, it's my honor to chair this Wednesday morning plenary session. We have two interesting keynote presentations for you. And so, without further ado, it's my pleasure to welcome our first speaker, who is Jan Martin Lovendahl. He is the research director in Gartner Research, specializing in higher education governance, strategy, and emerging trends. But he has a background before his time in Gartner in academia. He's a PhD in chemistry, experience in research, teaching, and IT management, and most recently, before he went to Gartner, he was CIO at Chalmers University of Technology. So I think he's very well equipped to tell us about his topic, which is what is the role of the CIO in the consumerized cloud world. So please welcome Jan Martin Lovendahl.
Thank you, David. So one first question here is actually, I'm in an audience I'm not usually used to. So how many of you have been or are CIOs, heads of IT directors of any kind? So we have a few, yeah, good. So at least I have some friends, I hope. Well, we'll see after the talk anyway. So what I'm going to try to do today is actually to talk about what NRENs can do to help out CIOs in this quickly changing world. So I'm going to use the vantage point of the CIO. And not only that, I'm going to touch on the experience I have as a researcher as well, because the story that you told is that really when I was a researcher, I complained so much about what IT didn't do for me. So they basically told me, well, you do it better then. And that's when I ended up doing IT as an IT manager and eventually CIO for about 10 years at Chalmers University of Technology. And that was at a time when we CIOs had control. I'll show you this nice picture that was given to me by an Austrian professor, also later CIO. And what she saw when she saw the Gartner hype cycle was a tsunami of technology hitting the classroom every day. And she was trying to make sense of this torrent of information and information technology. So when we do the hype cycle, that's what we're trying to help out with doing. We're trying to organize all these new information in such a way that you can make sense of it, and what is more important, help out your institution to be successful. And another question is, so how many of you have actually seen a Gartner hype cycle? Not everybody, okay. We have failed miserably, okay. No, that's good. Then I can do my favorite introduction here. So there's a technology trigger of some sort. It hits the press, and whoops, it's up to this peak of inflated expectation because it's going to solve all the world's problems. It's a new technology, hallelujah. But then somebody starts using it, and it plummets down to the trough of disillusionment because it's not going to solve all the world's problems. We can't really figure out what to use it for. And then, luckily, people like you hang in there, and we climb the slope of enlightenment and go into the plateau of productivity because we find out what it's really good for. And it turns out that this shape here, the hype cycle, which is about hype and maturity, really, and where hype is almost always much higher than the actual use you can get out of it. It's quite useful for most technologies. It's not the same everywhere, obviously. And my predecessor, Michael Sostroki, who's now retired, he used to tell me you can apply it to your marriage as well. I'm not sure about that. You tell me. So, one thing that's important to understand in this context is that we stop covering technologies or technology profiles when they reach about 20 to 30% of the intended market space. So this is truly emerging technologies. But as I said, when I do these things, and this is the education hype cycle, this is one of about 90 hype cycles we do in Gartner. This is 49 technology profiles out of 1,900 plus technology profiles. So when I do it, I try to do it from the vantage point of the higher education CIO. So what are the technologies you would need to cope with the future? And obviously, when you have 49 technologies, and even if you have this nice shape, you still need to do things like this. You need to try to understand what are the big trends. What are the things that actually are impacting the future of the institution? So in this case, consumerization is everywhere. Game consoles, campus app stores, mobile learning smartphones. Another big trend is obviously sourcing. So you can do anything cloud, and you can do open source. You can even do business process outsourcing. And of course, there are the old web application hosting kind of things. And in order to do that, of course, you need to do standard stuff, which is closer to what we're talking about here. We need to know about student information system international data. We need to know about technical standards like 802.11n. We need service-oriented architecture. And of course, we need stuff like federated identity and access management to make this happen. So I have the pleasure of being in charge of this hype cycle and put it together every year. So I can even invent new technology profiles when I think they're needed. And actually, the way we do it, you can actually take all of these 1,900 technology profiles and make your own hype cycle as well. But this is the toolbox end of it. And before that story, there's another story, which I think is even more important. And it's this story. And I'll go past these things. So consumerization is not only a solution, it's also a problem for us. And if there's one big macro force out there, it's really about the change of power from organization centricity to people centricity, and how consumerization and the death of distance helps make that change. And it's not only in technology. The death of distance, you know, we Swedes and also the Icelandic people, I hope, like their pickled herring. But obviously, it's not. It's costly to do the filleting of the herrings. So we fish it here, we put it in containers, ship it over to Thailand, they fillet it there, and then we bring it back and pickle it. And these are jars of pickled herring you can buy for about $1 or $2, or euro 2. So we have globalization that is impacting us on many levels. So the question I ask in that context, who has the controls of the means of production and distribution? And who recognizes that sentence? Marx, yes. That was quick. That's good. When I do this with a fully US audience, I think they know, but they're a bit hesitant to say. So, the question here then is, what does this mean for the traditional role of the CIO as a central dispenser of resources? Because when I put Marx out there, I put him there because I think we have the same level of revolution as the last revolution, the Industrial Revolution. The difference, though, this time, you're not going to have unions going and banging on your door wanting to have their rights on new services. They'll just disappear out and use services in the net. And you'll never see them again. So what we have now very often is this. They think we are the walled garden, slow change, alignment to institution. We give them the Blackboards and Microsoft Office, the ERPs of the world. They want open planes, lightning change, community of choice. They prefer WordPress over Blackboard or Moodle. They prefer things like Zotero and Soho and Google Apps over our Microsoft stuff. And it's kind of interesting that WordPress is preferred over Blackboard because it not only gives them more freedom, but they can actually give the students something they can hold on to after they leave the institution. Many institutions talks about the e-portfolio. Very few actually give it out as a lifetime tool for managing your learning. And of course, you can see the whole list here has something in common. Nothing there is controlled by the institution. So, in order to manage this, in order to be the institutional IT that adds value, I've actually devised this very simple graph. As you probably know, CIOs and senior management and Gartner likes 2 by 2. So this is services from a functionality specific to general and from a need point, local to global. And I actually used it before I started Gartner. And the main point was, as a former researcher, I want to make sure that the researcher understood I was not going to standardize everything. I was only going to standardize where it made sense, where we had economy of scale. And as a researcher, I had 8 different programs for rendering molecules. And yes, they did 8 different things. There is no way in hell you can make me standardize. So that's a cost I'll take. On the other hand, the issue I had with my own department was that there were a lot of stuff we were doing that was now commodity, where we did not add value. And the perfect example of that is actually email starts over here. In the name of economy of scale, we bring it out here. And then Microsoft and Google say, well, it's for free in the cloud. So with the same argument, I actually have to put it out in the cloud because that's where the economy of scale is. And we don't add value. And this framework served me very well for about 10 years. And then we had the consumerized cloud. And if I didn't put a service quickly enough out there, what did they do? Well, they went to Google instead. They went to these myriads of Web 2.0 services out there and did their thing, especially the researchers. Because obviously, I mean, if you're a researcher in chemistry at Chalmers University of Technology, you never collaborate internally. You always collaborate externally with Berkeley, with Ohio State, that kind of thing. So this tells me there's an issue of speed here that's pressuring the CIOs to be more relevant. And the question then becomes, can we do it all? Well, if you look at this very simple enterprise architecture light, I think this is the simplest version you'll ever see, at least from Gartner. The next version there has at least 5 layers. So this, if you have processes, so in theory, you will be able to map your information systems to them. And of course, you have a bottom plate of infrastructure to do that. Fairly logical. And it's actually a result of IT being a stupid tool. It only does exactly what you tell it to do. And in order to tell it what to do, you need to know what you're doing, and that's processes. Well, what is a CIO then? A CIO could be a chief infrastructure officer, a chief integration officer, or a chief information officer. So what's the difference? Well, down here, I'm all interested in networking and baseline identity and access management and stuff like that. Over here, I'm integrating services from all kinds of places. And up here, we have the chief information officer, who's actually at the leadership table, changing the way the institution achieves its mission in learning and research, because there are new capabilities in IT. And there's clearly a perceived value increase going up the ladder. And what do we do? Well, if we ask them, and we do actually every year, we talk to, last year in 2010 actually, we talked to 2014 CIOs all over the world. And we asked them, when are you going to put more than 50% of your infrastructure out in the cloud? The higher ed, the 128 higher ed CIOs said, well, we're going to have 64% said that we're going to have that by 2015. And the same question for software as a service, more than 50%, again, is 49%. And I say, wow, these guys can't wait to get rid of a lot of stuff out there. But then again, you know, I know how quickly we move in higher ed. I didn't believe this. because there's no way we can get to more than 50% of the infrastructure out there in less than 3 years now. Unless, and here's the clue, and here's why I wanted to be here today, because you can help. You're one of the foundations we need to make this happen. The NRENs all over the world. Here's some more realistic numbers. So right now we have 49% are already doing cloud, and in 2012, 67% expect to do it. Almost all of that is actually driven by software as a service and Microsoft and Google email offerings. Almost all. Not all, but almost all. But what's interesting here is platform as a service and infrastructure as a service. Small numbers to start with, but there's a huge interest in increasing that. And we're already starting to see people doing more specified multi-sourcing deals, where they go out and use things like Microsoft Azure, or storage service, or Amazon S3 services. And that's really interesting. So if the service is out there, people will use it. When in this survey, which we did last year, we asked them why they do this kind of outsourcing. Well, in the US, the top answer is they want to have cost savings. And if you look at the top 3 answers, EMEA even comes in the second as well. I think that's boring. That's not really why we do. Of course, there has to be a sort of cost-benefit thing about it. But the things that I really like are things that we start to think about. Is it a strategic decision to focus internally on core services? Or even more importantly, reduce time to delivery? And the real killer, I actually think, is this one. Quality enhancement through access to established best practices, service delivery, process skill. Realizing that there are people out there who do a better job than we do. Because we're very often about doing it ourselves, because we think they're best at doing everything. I think we're very good at inventing things. I think we're very good at understanding what the institution needs, but I'm not sure we're the best ones operating things and running large-scale things. So, even more interesting is, why don't people do more external sourcing? Well, this is sort of a catch-all. We want to keep competencies in-house, so it doesn't really tell us much. Things that tell us much is more like this. So a lot of legal issues. And actually, I spent a lot of time yesterday talking to quite a few of you, and that was the top issue. How do we solve the legal issues around the world? How do you make governments understand that they can't have too strict rules, or they need to allow some innovation in this area? Unfortunately, we can't do much of that ourselves. We need to push the governments to help change that. What we can do, on the other hand, is to look at things like this. A big reason people don't do more outsourcing is that there are no services out there that they can use. And sometimes when there are services, they don't do it because there is a complex infrastructure that makes integration costly. And that's when, and this, I'm going to test something on you. You're the second crowd that's going to see this example here. But I strongly believe, and that's almost all of my job today, I strongly believe we need to be better at communicating and getting a new language around change. Because in order for people to see what change needs to be done, we also sometimes need new words to make that change visible. So that's when I started thinking about this. So we've always used infrastructure as sort of a catch-all for all the stuff that we build upon. And it's a thing that underpins our organization very often. And when I think about infrastructure, it's often about road, sewer, it's electricity. It's sort of inorganic, it's sort of engineering. On top of that, we've always done exo-structure, which is inside support. And here I'm starting to use more of a biological approach, organic approach in the language. It's when, and we've always done this, is when actually, when you buy a piece of student information software from somebody, you take it inside and you make it a part of your endostructure. You copy IDs from outside, but you still make it a part of your internal structure. But with the net, with the depth of distance, we're starting to have more things like exo-structures, outside support. So if you think about the skeleton here, it's an exoskeleton. If you think about individual cells, it's slime mold. Anybody know about slime mold? Heard about that? Good. I have to show a slide about that eventually, but you have to wait a bit. And when you talk about intraspecies interaction, this is more about ecosystems. So you need to think about living inside an exostructure that supports you from the outside, rather than building on top of an infrastructure. And of course, if we continue this thinking, there needs to be eventually probably a suprastructure. That's probably going to be things more like houses, but eventually, if we find a way to do climate control for carbon dioxide, I think that's a good example of a suprastructure. Standards. I love standards. So if you look at this axis here, you start in the middle with more specific industry standards, working with endostructure and exostructure. And when you get to the infrastructure and suprastructure, you have more generic standards. And it's like the need for language of a change. So there are many words for snow in the Sami language. And I think we need the same thing. This is starting to get so important now that we need to get better at telling people what we need and how they should align to that. And now the slime mold example. This is really cool. So this is basically a single-celled organism, but when food is short in supply, they aggregate, become some kind of slime that actually can move, can specialize some cells because they're going together. And more importantly, which is huge, I think, they actually can start solving problems they couldn't solve as single cells in order to get to food. I think this is a really cool example of what real exostructure can mean, because obviously they have to have a common chemical language of some sort to do this. A common DNA language in order to make these changes of these cells. But I digress. So, I want to give you examples of what I think is the exostructure, what could be the exostructure. So obviously we said we have to move away from the old control in terms of hardware and software and stuff like that, and move to things like IFAPs and services. So IFAPs is a very technically oriented exostructure, and services is a more soft way of defining the exostructure. So, what is IFAPs? Many of you will know this, but I have struggling to explain this to CIOs. And I know I am among friends when it comes to standards when I'm here, but you have to understand also that a lot of CIOs actually do not have the level of understanding that you have. And you have to start as a pedagogical level in order to explain why these things are so important. And I think that one of the best analogies I found is this one, with the standardized container, which totally revolutionized the shipping industry and transport industry in the 50s. So what you have here is a standardized narrow waist on which you can build infrastructures, boats, trains, cranes, trucks, who transport these packages. And inside these packages, you can basically load anything. And that's exactly, obviously, what we have with the internet and the TCP/IP. And the key thing here is that these things, if you do them right, they set your data free. And I like Google Data Liberation Front, because they ask the right questions. They're very simple. So can I get my data out? How much will it cost? How much time will it take? A good exostructure is really dependent on getting your data in a free flow format. Okay, so why am I hooked on IFAPs? Well, IFAPs is identifiers, formats, and protocols. We just talked about this basic one we all know about. There's a very usable one, which some of you hate, I guess. But I love it because you can basically, because of, you have the address, everybody has an address, you have a very free flow format, MIME, you can send anything basically over the protocol, simple mail transfer protocol. But of course you also have this, and this is what I want to stress. A good standard, a really, really, really good standard is built like this. So uniform resource locator, hypertext markup language format, and HTTP protocol. Obviously, it's good because it was designed to be good. And for those of you who were offended by Marx, I'm going to try to offend another set of the audience here. So I see this as a trinity of standard checkpoints. This is what every good standard should have. And we need to make sure that people out there understand this and make and build standards that are done like this. And there's no lack of it. We have the web standards. We have identity and access management. And of course, this thing here is the really cool thing, because that gets closer to those industry-specific standards in the exo-structures I was talking about. And actually, I would dare to say that we were first in higher ed to do this, because we knew it wasn't enough with just authentication. We have authorization and role-based authorization as a goal. The problem, though, is we're not using it enough, I think. But what's even more interesting is when you look at non-IT standards out there, ISBN, financial audits, charge of accounts, and try to even look at non-IT students or education standards. What can we do with them to make them machine readable and used in an automated way? I love things like metadata for learning opportunities. It's there to help us do real Bologna, make sure that is the best fit among students, what they need, and what the universities give all over the 45 or so national governments who's in there. I love things like when the Spanish government actually have a standardized format for teacher CVs, so that the job market within Spain becomes easier. So we need to understand what things like down here, which are already out there in the real world, can we exploit to do new exo-structure IFAP standards to expand the world. So this is a job for the NRENs. And the reason it's a job for the NRENs is because you've already done it. You know how to do it. You have the processes. You have the skills. We just need to find more examples like that actually gets closer to the end user's needs as well. So, services. Services is one of my other big, almost holy grails, because I think services is the way you eat the elephant. Services is not something you can really touch. It's more like a meme. I don't know how many of you have heard about Richard Dawkins' meme. A few. So it is about having a good idea that helps you organize things and that sticks. So I'll give you a story of how I actually have used it in Chalmers at one time. So for me, it started being a way of telling people what I was doing and making it comparable between years. And what I was exploiting, the meme I was exploiting, is that everybody understands the price-performance discussion, because they've all been to MediaMarkt or whatever, and they understand why you have to pay more for a 52-inch screen than a 32-inch screen. So you don't have to teach them about this. But when you take the next step and build an endo structure around this, It's when you force your other IT departments, and most of us who come from research universities have very decentralized IT departments. So if you force everybody to use the same way of comparing the services, then we can help each other out and producing the best service possible for the institution. And in my case, it actually, what happened was that we started comparing between different IT organizations. We went from 20 to 12 to 8 to 5 to 3 to 1 IT department within Chalmers University of Technology. It took us 7 years. But nowhere under that process underway, there was a centralization decree from the rector, the vice chancellor. No time. So people will do the right thing when they have a mechanism for doing the right thing. The key, though, is not about doing it in the endostructure way. The key is to do it in an exo-structure way, so that you start to compare yourself, you start to define your services in the same way as external institutions or organizations or vendors define the services. Because then you can start, and this is the final reference to the big three. The final reference here is that you can start to get an evolutionary pressure on the best service, fit for purpose, out there. This is a very soft way of approaching it, but it's a very important way of doing it. I'll give you this because it's not only about how you define services within an IT department. It's also about using a concept that works all the way up to the senior management. So I, as a CIO, is very dependent on having the same meme, the same concept that can aggregate all the way up to the institutional level. So in this case, we have the service catalog, which is services defined in the way that IT produces them. And there's a simple example. You have a secure service, a secure storage service, you have a normal storage service, and you have a cloud storage service. All those are distinct, different services within your institution. And usually the service catalog is something around 150 up to 250 services. I've even seen 650 services out there. This is useless bringing up to the buyers within the institutions, the senior management. They just get confused. They don't understand this. So you need to devise something called a service portfolio, which is services defined in the way that end users consume them, or actually rather in the way that the president or the vice chancellor pays for them, which is very different. It's actually defined more of the attention span of the president than anything else. So usually you have to have about 10 services. That's the maximum there. And of course, on top of that, you have your project portfolio, which operates on the service portfolio to bring new capabilities. In this context, what I need from you is more NREN options here, because the service catalog, that's my sourcing tool. That's where I start balancing things like internal storage with external storage. So when over time, because we all know it's big bang changes does not really work. So we need to do multi-sourcing approaches, where I have a choice to do step-by-step change of my sourcing. And that's the big thing I think is lacking in the NREN world of today. And we've said that for, 10 years. We already have the technology to do federated identity and access management, but very few uses it because we don't put the services in there. So we need to build services that cater for the end user. And what do I mean by exo-structure services? Well, one of my favorite examples is DuraCloud. So these people actually use open source, which again is sort of an exo-structure agreement, and combine it with commercial cloud storage, and you have a digital preservation service. That's really good. It changes totally the dynamic in digital archiving. Surf Connect is another one of those really cool examples where you use consumerized exo-structures in order to focus on collaboration for researchers. That's a good service. And of course, Internet 2 with the box agreement. Sort of looking at the legalizing issue. So that's another way of getting to these legal problems and IP problems out there. Somebody who has the expertise can go in there and do the negotiation for a larger group. And sort of an internal one, mixable by Purdue. And this is actually one of the more cool ones. So they understood we have good internal endo-structure data about our students and faculty. We only need to hook that up with existing consumer services, Dropbox and Facebook, and we have ad hoc collaboration capabilities. But the interesting thing is that the CIO of Purdue, he does not want to run this service. He wants somebody else to take it over. And I think that's one of the key things you can do as well. You can be the trusted brokers who are the brokers between us as CIOs, who are usually very poor at vendor management, who don't have time to do all this procurement stuff, especially if you're based in the European Union. We need somebody who do that job for us. So you don't even have to deliver those services. You can be the broker who make these services available in a trusted way. So, the next to final slide here. How do we apply this in this model? Well, the IFAPs is really a key point down here. It's about building the infrastructure and also doing the integration here. But as a chief information officer, I'm more dependent on services. And of course, if you translate that, that's the service portfolio and that's the service catalog. So to recapitulate, we have a quest. I'm asking you to help me find these services and IFAPs that we can use. And I'm sure you know more than those 4 examples I showed you before on what I think are good extra-structure services. So please, please, please let me know what you have out there. And I'll help you market them to the community. And my final slide is something I always end with in this kind of environment. Those of you who have read your history understand why there's sentences out there, but this is what it's all about. Standards enable flexibility. And if you don't believe it, this is the classical Lego box with a 3-in-1. So you can use the same pieces to do 3 different Lego structures. A boat, trucks, a boat, a helicopter, and a car. And those of you who either have children, grandchildren, or simply want to play with Lego, first come, first serve after the talk, and you get them. But never, ever forget that standards enable flexibility. Thank you. Three minutes ago.
So, thank you very much indeed, Jan Martin, for that. So we have some time for questions and discussion, if we can see. Who wants to be the first?
It's still early.
Don't be shy.
Have you all had coffee?
So maybe I could start by asking you, you describe several things that the NRENs can do, right? I mean, if there's one thing that you would like to see this community help you with, what would be that one thing?
Well, the one thing I think we need to solve is to have services that the end user understands and can use directly. And I do know there are several communities like Switch who do this very well. But we need to build them as services in the service catalog or a service portfolio that makes sense to the end user. Because if we can get the students to want this, then we can put pressure on the institutional leadership to get this eventually.
Okay. I see a hand up. Is it Leif over there? Just keep talking, they'll turn it on.
Talking and now. So I'll give you a curveball. So the Lego analogy is pretty apt. Because, as you probably know, Lego, they're starting all of this sort of custom pieces and things that can only be built into one thing. And what is stopping us, or how do we stop the cloud providers from locking us into their offerings once we go there?
That's a good question. But they're also doing interesting things with the social side. So they're connecting their users in a way that they can understand better what they want as well. I think we need to do that bridging as well. But to your point, there will always be big mega vendors that will try to stop us from doing the exo-structure.
Okay, we have a question over here. Case to lab.
Test. Okay, so small question.
Over here
I'm
on the
here.
side. Maybe.
So how much does Gartner itself for its own IT services outsource? And where?
I'll give you an example. So 2 years ago, we wanted to do the streaming thing we're doing here, and also making it available on the web. So one of the senior executives asked the internal IT department, so how can you do this? Well, we need $500,000 and we need to do it takes us 6 months. And he said, doesn't cut it. So he went outside, so for $100,000 and 2 weeks, we got the service up and running.
Well, I would, of course, think about you must have enormous databases with the strategic data, which you then sell back to us. So do you put that data in the cloud? And do you do anything of your IT for your basic business in the cloud? So do you eat your own dog food?
No, we don't. That's my big frustration internally. I've been trying with Layfair for several years to get us to use federated identity and access management for universities to access Gartner services. Doesn't happen. So we're cobbler's kids in that respect, unfortunately. But it doesn't, we can change the world anyway, even if your own organization don't understand it, of course. Isn't that right?
So we have a question here at the back. May even be Niels, I'm not sure.
I'm afraid so.
Yes.
I think your presentation and the exoskeleton model is very suitable for campus services that you want to outsource. But we also deal with a lot of scientific resources and scientific services. Could you say something about that? How would that work? Especially given the fact that most of these services are consumed by very few users on a given campus.
That's a very, very good question. And as I tried to point out in the beginning, I have the institutional CIO view first and foremost. That's what I'm trying to change there. I think, actually, the DuraCloud example is an example of how we help researchers solve a problem, which I couldn't have solved myself without a lot of cost. So I think that is going to be topic-based communities who understand what kind of service they want. And that's always been the case. But if I look at this from a societal point of view, the problem is not actually research, because research has its own funding ways and collaboration ways. The problem is delivering education, higher education, as a cost-effective way. So that's the problem I'm trying to solve here, first and foremost. But that's a good question.
So I think I saw a question here in the middle, please.
So you'd indicated that you've been trying to get Gartner to move, but based on your model and what you've described, Gartner has no incentive to do so because of its desire to maintain all of its own control over its community. It doesn't want an exoskeleton to exist. So what I think I heard you say is we all have to stop subscribing to Gartner to get Gartner to do what we need them to do, which is to participate in our exoskeleton.
Sure. Well, the thing is, we actually do have it already, which is through Burton, which we bought because we thought they had a better identity and access management service, for one thing. But yeah, that's the way you do it. That's how you do it. You put pressure on people to change and be a part of it. And actually, in that context, what I can do is I can truly recommend the book Non-Zero by Robert Wright. So he explains the social, cultural evolution of mankind with game theory. And that's a really good book because you can see how trust And cost of information and diminishing the cost of information can increase value and create a win-win situation.
But in a consumerized IT world, many of the providers are purposefully identifying solutions to go around any control at the institutional level. They're looking for individuals to subscribe. But institutional CIOs are also in a position of being risk managers, and they aren't in a position to accept the terms that individuals are willing to accept. Yet the individuals don't realize they're in fact accepting those on behalf of the institution. How do you reconcile those two positions?
Well, that's where I come back to. We need this language thing again. We need to tell them why it's a good idea to use the Extrastructure institution version rather than going out to, infrastructure, microsourced thing from Google. And one of the key things there is how can data move between different users, for instance. So we can be a guardian of making a free flow data. And if you go directly to a microsourcer like Google, whatever, then you probably diminish the possibility to use that data in many situations. But this is pedagogy. This is why we need people who you have the right language, have the right credibility, can go in there and help them see the light, basically. And to use another chemical model, the potential surface of this space, in a sense, is constantly changed by catalysts that will make people go in different ways. But until we've saturated Facebook, for instance, until Facebook understand that they need to move data between Facebook and the Chinese equivalent, I don't think we can get to the next step. And that's again why we need those services, specific services that help individuals do their job better. Because then we can make them change, make them want to change. We can never lock them in. I mean, I know many institutions have this policy for security reasons, you can't use Google. But that's ludicrous. At least 15% of the faculty do anyway. So that's obviously not the way to do it, to your point. Thank you.
Okay, so I think at this point we should move on. So let's thank Jan Martin again. And so for our second keynote of the morning, it's going to be a pleasure to welcome Jacob Appelbaum. So I'm reading from the bio that he has on the TNC web. He is an accomplished photographer, software hacker, and world traveler. I can attest to the world traveler because he just flew in this morning on his travels from somewhere to somewhere, so it's nice he's here. He works as a developer and a core member of the Tor project, and is also as a staff research scientist at the University of Washington Security and Privacy Lab. Amongst other things, he is a founding member of the Hack Lab Noise Bridge in San Francisco, where he indulges his interests in magnetic cryptography and consensus-based governance. So today, he's going to tell us many things, I'm sure, particularly on the Tor project and practical censorship resistance. So please welcome Jacob Appelbaum.
Thanks. Thanks so much. Get the little clicker. It's really quite an honor to be back in Reykjavik. It's nice to see some of the people that I've seen previously here. I'm extremely tired as I literally just arrived from Seattle by way of, well, actually San Francisco on my way to Brazil. It's a little stop out of the way. But anytime I can come to the Scandinavian and Nordic countries, I pretty much try, even if it's only for 23 hours. So hello. If there's at any point a question, probably instead of waiting until the end, interrupting me would be better, because I think that will make for a more lively discussion. I don't know if that's actually not allowed, but try it anyway. So I want to talk about something that is a little bit controversial in some places, but a lot less controversial here, I think. But basically, I want to talk about anonymity and censorship. And first, I'm going to introduce Tor, which is the project that I work on with a large number of other people. So it's a free software project, and that's free as in freedom, but it's also open source, as in, you can read the source code. It's based on an open specification. It has a whole bunch of peer review, and it is essentially a thing that anyone, given the information about the design of the system, can implement it. In fact, there's one guy who actually implemented it almost entirely on his own in a couple of weeks from scratch, whereas Yale and Aachen and some other places have done their own, and their implementations have helped actually catch bugs in our implementation. Ours is written in C, several of the others are written in Java. Having open specifications, just like open standards, helps to sort of make sure that things are as you expect them to be. These days the network is growing quite a bit, so as we see here, it's about 3,000 relays. It's like somewhere between 400 and 500,000 active users, and the network is pretty big. And we're a non-profit, which means that essentially everybody is working on this instead of working on like, a lot of us that work on it could be working at places like Facebook or something like that, and we thought, well, maybe there are enough people working on Facebook, we want to try something else. And I think we're one of the only free software projects that's been funded by both the Department of Defense and the Electronic Frontier Foundation, which I find like a little bit of pride in that. I think that that's really quite hilarious. I mean, it just goes to show that not every organization is bad and not every organization is good just because they happen to fund something that's awesome. So if we look at anonymity, when I explain to people that I work with that at the University of Washington, for example, if I explain what Tor is to someone who's a computer science student, I usually talk about it in terms of traffic analysis resistance. So everybody here that runs a big network, I'm sure you have some knowledge about traffic analysis. I mean, it might be through having some kind of like flow-based analysis or something for your network. But when I talk about this with human rights activists, usually they care about it from the reachability perspective or the privacy perspective. Sometimes they also care about it and they call it security. But what they really mean is I want to be able to circumvent censorship. So this, for example, if we look at this, these are some screenshots from various different places around the world. So this one, for example, is Kuwait. And these are great, right? They're trying to tell people, this one is, I think, Saudi Arabia. I think this is Bahrain. But basically, as you can see, some of these are like Android devices. Some of these are actually web browsers, like real ones. If you actually fill this one in here, you can say like, oh, my website's blocked. Here's my email address. I'd like to comment about that. I sure wish it wasn't blocked anymore. Then the government of Bahrain, for example, or no, that's the Sultanate of Oman. They'll say, oh, no, it was really intended to be blocked. That was not a mistake, which I think is hilarious. I like that they have that form. The best part about this form is that it's an accidental circumvention tool as well, because when they send you an email to tell you that, for example, torproject.org was meant to be blocked, they actually base 64 encode the email in this kind of weird way, because their DPI devices don't do base 64 decoding on the fly. So if you want to circumvent it, you don't even need strong encryption. And they do that to circumvent their own censorship system, which gives you an idea about the visibility of their own circumvention prevention program or surveillance program. So this is part of what we would like to, well, frankly, get rid of. Right? This is an example of, as a good friend of mine, John Gilmore, often is quoted as having said, is the internet treats censorship as damage and routes around it. So this is damage, right? And really, if we want to get rid of that damage, we need to do a couple of things. One of the things we need to stop people from being targeted, right? Because when someone is blocking, say, access to a website, this happens because someone is able to find a distinguisher in their traffic and say, well, there's no confidentiality, so I know the URL they went to, and I match it against, a block list of some kind. Maybe in some cases, they actually modify the data, which is, I think, pretty bad news. But most importantly, if you have to register with your real ID to get an internet connection, you actually don't have privacy in the sense that there are so-called law enforcement agencies all across the world that like to target people for man-in-the-middle attacks and then break into people's computers, usually using commercially available software. And one of the examples of this is a thing called FinFisher, which is well known from the WikiLeaks spy files. And it's pretty scary stuff. But the way that people are usually targeted starts with the fact that they actually just don't have privacy in anything that they're doing, and they don't have confidentiality, and they don't have integrity. Whether their automatic update for their, like, say, some of the software on their computer is vulnerable to an attack, or whether it's that they downloaded a program and since it wasn't over SSL, they can dynamically rewrite the binary. There's all kinds of other stuff that goes into it. So whenever things like this pop up on the screen, that's an example of a protocol that usually is insecure. These are all HTTP in this case. These are some other ones from the Middle East. Most of these, though, are designed, in order to give you an idea of control, or rather to sort of assert control. This one, I think, is one of the most egregiously disgusting censorship pages I've ever seen. And the reason is because they're trying to suggest in Qatar that it is an accident that you see this page. Right? This is a kind of social conditioning. So the thing that I find particularly sad about this is this company, that company. Who do you think builds these things? So, it's a little depressing actually, because, these guys right here, for example, are probably the biggest example of a company doing the wrong thing. Even though I think in some cases they think otherwise. If you read some of the slides that they have out there, they even include slides talking about how you should buy their surveillance systems so that you can hunt down, unwanted groups of particular religious or other ethnicities, which is like incredibly scary to me. So this is just kind of the start of it, and this is just the stuff that's public. This is for simple stuff. It gets way scarier when you go to other countries. But first, a crash course in Tor. Basically, I wanted to see who in the room has actually used Tor. So raise your hand if you have. Yes, okay, so the crash course is going to go even faster. Basically, the deal is that Tor is a peer-to-peer network. If everybody in the room right now were to start a Tor relay on their computer, the network would actually grow tremendously, since this is a land of fantastic bandwidth. But basically, it's for TCP communication. So it provides a local SOCKS proxy, or it provides a transport. So if you have IPFW or IP tables, you can redirect traffic right into it. The basic idea is that each of your computers, if they were a relay, they would publish to what are called directory authorities. The directory authorities get together every hour. They look at all the nodes that have published to them, and they say, okay, that node, it's reachable, it's fast, I'm going to publish some information about that. And now the clients connect to the directory authorities, and they pull down that information, and that's the network, in short. There's a whole bunch of stuff that I'm skipping over, such as the cryptography, how we actually do measurements and things like that. But the basic idea is the same. The directory authorities are run by, at the moment, 8 trusted people around the world. So instead of having a single point of failure, we have, I guess, 8 points of failure. But lucky for us, basically 4 of them can go away and we'll still be fine. The cool thing about this, I think, is that you can basically know, thanks to some compartmentalization, that if someone in this room is your first hop in the circuit that you build, then the rest of the nodes can even be bad to some extent. And your risk is compartmentalized. So if we look at it from the perspective of, let's say, the most simple diagram, these are the relays any of your computers can be. These are the directory authorities. These are other relays, which also happen to run a cache. And basically, the cache caches the snapshot or the consensus, the list of servers in the network itself. So basically, the way that it works, I mentioned a circuit, is that Alice builds a circuit through 3 hops, which she chooses at random. So if there are 3,000 relays in the network, she chooses 3. And she has a very basic constraint solver. And the idea is that the first hop has a certain set of flags. So I mentioned that the directory authorities sort of vote. They look at the properties of the server and they say, okay, it has these properties, and then they publish that. Well, so this one would have a guard flag, for example. And this one would exit, or have an exit policy that allows you to go to reach Bob. Let's say Bob is actually twitter.com. And the reason we have these little colorful lines, which maybe I hope you can all see, but they're actually TLS links between these relays and from Alice to the relay. And then inside of that, we do a half-authenticated Diffie-Hellman. So Alice knows she's talking to relay 1 because the public keying information is part of the consensus that Alice downloaded. And this is ephemerally keyed twice. That is, the TLS layer is ephemerally keyed, and then there's a session key that's established with relay 1. Alice then extends her circuit to relay 2 through relay 1. Relay 1 knows about Alice and 2. However, as soon as Alice extends her circuit to 3, relay 1 only knows about 2 and Alice still. So now we have compartmentalization. What that means is that relay 2 doesn't know that Alice is in Iceland, and relay 3, of course, does not know anything about relay 1, only about relay 2. And if Alice is going to Bob or Twitter or whatever it is, and she's using TLS, relay 3 sees someone from relay 2 is exiting through her or through his relay and out to Twitter, and you just see TLS traffic. So that means that Twitter, of course, sees the Tor network. So should you, for example, be subject to some kind of legal subpoena, talking about cloud privacy earlier, right? This is a nice thing because it means that even if that company were to give up the data, they wouldn't actually see your location, right? So we sort of solve some of these problems. So that's a lot of text. And I'm not going to read my slides because I hate it when people do that. But basically the deal is this. If you have a single hop proxy, relay 3 can betray you. Relay 3 knows where Alice is, knows where Alice is going, knows probably what Alice is saying, and you have serious problems. Not the least of which is that without that compartmentalization, you can have pretty selective censorship by the network itself, but also of people trying to reach the network. So single hop doesn't work. 3 hops we think is a good idea. In some cases, the right answer is 4. And there's a bit of it information that I can get into if anyone cares about the actual number of hops. I think that's kind of irrelevant. But so there's a problem with this, and I'm going to show some graphs in a little bit about what's wrong with this picture. But if Alice wants to download this, there's a bootstrapping problem, right? If Alice needs to download that list, that consensus, whether it's from a cache or the trusted directory, well, Alice has to download a list from a set of IP addresses. As a bootstrapping problem, that's really hard because if you have someone who's blocking access to websites or blocking access to particular IP addresses, the firewall, for example, between Alice and the rest of the network just drops everything, and what happens, right? Access to the network is blocked. And that's a pretty big problem, and we'll get into that in a second. This is something I think which is important, which is who here has ever thought that Tor was a little slow? Yeah, okay, so you're not alone. Here's some data to back that up, which is that if we look at this here, we see 10 seconds, upward actually, to 30 seconds to complete a 50 kilobyte request, right? But as it just so happens, basically in 2009, 2010, this number was hovering around 10, but these days we're down to about 2.5, which is pretty good. I mean, when you consider the fact that it's all volunteer run, and it's an anonymity network, and it gives you these crazy properties, I mean, you know, it's not fantastic. It could be a lot faster, and it will be in the future. So for 1 megabyte, for example, we see this was 50. Now we're getting down a lot closer, right? So it's actually starting to be the case that it's getting a lot better. This is horrific. We are no longer at horrific. So Tor has some problems with regard to TCP congestion, which is, I think, probably one of the biggest problems that it has, which is that if in each of the circuits that are built between each of the relays, if many clients are connecting from relay 1 to relay 2, because of course there are many clients that are doing this, you have this hilarious problem, which is that with TCP, you basically only have one thing you can do, which is, hey, slow down. And all of the multiplex circuits over that single TCP connection all get slowed down all at once. So one top talker pushes everything down. So we're trying to work on that because it will actually mean that even if there's an extreme an extreme heavy BitTorrent user, for example, they wouldn't be able to slow down the network for everyone else, in that the relay could actually rate limit it and say, this client, this circuit only gets X number of bytes, or something like that. And we'd be able to enforce it. And so you can actually see for 5 megabytes, you know, it was pretty bad. And it was really bad here. And now it's actually significantly better. So if you thought it was slow before, and you're used to like really nice Scandinavian networks, it'll probably still be kind of slow. But, you know, comparatively, it's a lot better than it was. So of course, I sort of have to toss this in here. It's important to note that, you know, a lot of people look at internet censorship and they think about it as a problem in over-there-istan, which over-there-istan is like maybe the best way to put it, which is that, it's in China, it's in Iran, it's in Qatar. But, if you try to go to the Tor website and you're in British Columbia, in Vancouver, for example, at one of the main sports centers, I found, for example, that I could not download Tor. They actually blocked access to our website. So, ultra left-wing Canadian West Coast city is in the same crowd as these folks. So one of the ways that we've been dealing with that is, people that trade wares probably remember this, but you could send an email and get software in return. I thought, someone needs to write a free software implementation of that. So I did. And GetTor at torproject.org is a free software program that is basically like a remote shell. People send an email and we'll return them source code or binary GPG signatures, whatever they want. So we use overlay networks to reach our overlay network, which, it's ridiculous, except it actually is used all the time. And you can see important political events come out in these graphs. So, that to me is pretty fantastic, actually. So, this isn't a huge number of downloads, but considering that these are people who clearly had no other way to do this. If you're going to download software, you probably don't want to do it via email. But, if you had no other choice, this is a fantastic way to do it. And since the GPG signatures are available, you can, of course, verify that it's totally kosher and you're in good hands. The other nice thing is, since it's free software, we've encouraged other people to set this up for the communities that they're in. And they can just set up a .forward on a Unix system, and they can deliver any software they want, actually. And it's the simplest possible thing that it could be, but no simpler. So China, for example, is probably the best example of this. All of the Alice users in China, and some guys from Sweden actually have been working, guys and girls actually, from Sweden, have been working on making it possible to understand this part of the Chinese firewall. People sort of refer to it as the Great Firewall. I like to refer to it as the not-so-great firewall. And this has become so advanced right now in China, mostly thanks to Cisco. This is ridiculous. It actually does protocol classification on the fly, of crazy fast, high-speed links. It classifies the protocol, and if it decides that it's a Tor connection, they fire up a forked copy of Tor that they forked, and they connect. They tune their TCP stack in a particular way. So actually, it's kind of funny. If you tarp hit the first connection, then the probe fails. There's a whole bunch of fun stuff you can do with these firewalls. But the other thing is that since they're running our code on their machines, there's even more hilarious things going on there. But your mileage may vary. But the fact that it does this kind of automatic protocol classification before connecting is totally crazy. It's really intense. And then they decide, for example, when this client connects, they just pick a random IP address from all the IP addresses that are available and routed from behind the actual firewall. It just blows my mind to think of that. So it's state appropriation of all IP addresses, and they just pick one at random and make a connection out, and it routes back to them, and they decide whether or not that's okay, and then they either tear down the connection or drop all the packet. They have a couple different modes. It's horrifying. It's powered by, I think, Cisco for that one. So we came up with this solution, which, for simplicity's sake, we're going to just call it Bob the Bridge. So we took a problem which was, how do we give out every IP address of every Tor node in the world, but not give that out to the, say, Chinese government or any network administrator? And we decided that was an impossible problem, because in order to build those circuits I mentioned before, you actually have to have them. So if you have to have them, and you also have to keep them a secret, you can't win that. So we decided instead we would have a thing called a bridge, which all it does is do the first hop business and connects you to the Tor network itself, right? So it's a bridge. It bridges you between an internet that is filtering direct access to Tor, and you bridge through it. Because of the protocol classification, there's an arms race, and unfortunately this doesn't really work in China anymore, actually. So it's crazy. So we are now designing protocols such as the obfuscated or OBFU protocol for OBFU bridges. That is, bridges where the protocol is intentionally designed to be incredibly hard to classify. So variable packet lengths, all different ports, you name it, right? It's like we just try to make their day as hard as possible. And in fact, in places where Blue Coat, anybody here use Blue Coat at all? No? Nobody? That's good. Don't give those guys your money. So, I mean, seriously, those people are probably responsible for a lot of people getting their heads cut off and shot in Syria, right? They violated the sanctions in Syria, and people are being murdered in a civil war right there, and they just do not even seem to care. Anyway, so their protocol classifier doesn't work for the OBFU bridges, which is kind of nice. So if you happen to have someone who's traveling to China or traveling to Syria, you can use and set up a private bridge where the IP address is not known to the authorities and the protocol is very difficult to classify, and then you're back and you're able to connect to the Tor network. That's really useful to be able to do that. And now, the remaining 17 minutes of my talk, I'm going to jam through the current state of the network. But that's a brief overview of Tor. It's incredibly complicated. But luckily, all the specs and source code are open so that if there's any confusion, you can just read it. But are there any questions so far? You guys are really quiet. Yeah, you have a question? I was going to point at you, but it's a green laser, so it's probably a really bad, really bad idea.
So the question is, where do you see that arms race going? I mean, eventually, your obfuscation might lead to crazy stuff like hiding stuff in images, and what's the end game there?
Well, freedom for the whole planet, where every person has the right to read without exception and the ability to speak freely without having to ask permission. That's where it has to lead, right? I mean, the thing is that technically speaking, all of these things are easy to circumvent. Making it work at scale is a little bit more difficult, because if you have to give away something that is a secret and you give it away to the people that are the attackers, that obviously doesn't work very well, right? So bridges, for example, we have what's called a bridge database. All of those bridges were harvested by the Chinese government. They maybe ran a botnet or something and just requested as many of those as they possibly could, and eventually they exhausted our supply. So in the simplest sense, these firewalls are very socially successful. So for these firewalls to go away, we need several things. Probably one includes some kind of control. That is to say, we limit arms, right? And why is it that we limit arms dealing? Well, it's because we understand the human cost of this. Well, surveillance and censorship are part of that same framework of arms. So for example, landmines. We've generally banned landmines. Now there are some rogue countries like the United States that don't care very much about that, but and they use other things like white phosphorus and so on. But if we just look, put that aside for a second, and we say that there are some countries that respect human rights in the world, those countries that are doing that, they could help, because for example, Nokia Siemens, they sold so-called lawful intercept gear to the Iranians before the Green Revolution started. Maybe they could have thought about whether or not that was a good idea, right? And so dealing with the social aspects of it, I think, is very important. We're mostly dealing with just the technical aspects, but there's an ethical question here, which is that when you implement so-called lawful intercept, you put yourself in a position that is maybe a little bit dangerous, especially if you happen to be in a position where you have no way to really verify the person that's making the request. I mean, if Google can get owned, so can a local police department. So the fact that it's even coming from a local police department might be very convincing, except it may not be who you think it is. So building in these kinds of backdoors actually builds in a sort of weakness. And of course, when we export these kinds of devices, we export those kinds of weaknesses, but we also export those kinds of power and control situations, right? The Iranians are not going to build their own, mass intercept devices. We can see this because, in fact, they purchased them instead. Now it's Huawei, I think, that's building it for them. But, obviously we can't control it forever, but we should consider the social impact of such a thing. And like landmines, surveillance and censorship equipment, they're in the category of arms. And in the case of Syria right now, for example, when Blue Coat does network filtering and logging of people's internet connections, those people will get a visit and their family will be cut up into little boxes and shipped home. right? So there's a direct relationship between surveillance and murder in places like Syria. And that's very scary for a lot of reasons, not the least of which is that that actually happens to people, and they're only a couple degrees away, maybe only one hop away. So I hope that answers your question. Any other ones, real quick? We're going to go to some graphs. Okay. So here's the total bandwidth. So as you can see, this is in megabytes a second. We didn't really gather this data quite some time ago. The metrics project is about 4 years old with the Tor project. It's a sub-project inside of Tor. This is actually the 10th anniversary this year of the release of Tor. So we're doing pretty good in terms of, I think, 10 years of progress as a free software project. So in 2008, we were, at like 250 megabytes a second. And now we're like, going up on our way towards, 3,000. So we're really growing quite a lot. And that really pretty much entirely comes from volunteers that have fast network connections, installing the software and just forgetting about it. And it just builds the network. And that's very helpful when people do that. So every Unix beard in this room can help make the world a better place with like 4 commands on their computer. And it's like really easy to do that. And I would highly encourage you to do it. And this here is the advertised bandwidth. That is the bandwidth advertised. And this, of course, is the history that has actually been recorded. So we see that the bandwidth is raising, and not just in the sense that people advertise that bandwidth, but actually that it's what has been observed. And we also see, similarly, just from 2010 until now, that the nodes and the bridges in the network, bridges are about 500. We see that our metrics project had some errors here, but now we've basically doubled bridges in a year. That's pretty fantastic. We've also gone from somewhere around 1,600 relays to close to 3,000. A lot of this comes from the fact that I would never try to take any credit whatsoever for any of the crazy stuff that's been happening around the world, but sometimes people wish that they had some agency for change, and so they say to themselves, what can I do to help what's going on in Egypt right now? People need access to information. I want to help with that. And it's amazing because I'm pretty sure this entire growth right here, going from about 2,000 nodes to 3,000 nodes, and right here from 1,500, of course, all the way up, that actually comes from people saying, I actually do have the ability to make a difference. And so they do it, and they install the software. And as a result, our node count is like ridiculously grown in just a short period of time. And I like to show some kind of local graphs. So I was kind of sad in 2010 and 2009 that there were basically 0 or 1 Tor nodes in Iceland. But I'm really happy to see that these days we're getting up there. 6 is pretty good. It's a lot better than 0. I think if there are people in Iceland here that have computers, you can install this and you can make that number go way, way up. If we look at the number of users, again, the metrics project here, it's lacking data from before because we weren't collecting it and analyzing it. But basically in 2009, we think that there was somewhere around 150,000 users or something like that. And then it just kind of started going up. And these are estimates. And the way that we build these estimates is we do a GeoIP lookup for the entry node, so the first hop in the network. And we look at it and we say, OK, put it in a table, and we say, oh, OK, there's 1. Every 24 hours, we report this back to the metrics server. We don't report the IP address back. So it's a compartmentalized design. So we can actually divide it up by GeoIP of the country. So this is really interesting here in that we see that we spiked over 800,000. It's not exactly clear why. It could be that we had a glitch in our metric system. I mean, anonymized data collection like this is actually incredibly difficult. So we think that this is about correct right now, which is about 400 to 500,000 users every day. And they're not necessarily the same users. So if I start Tor on my laptop here, but then I am on an airplane to go to Brazil, obviously I'm not going to show up for about 20 hours. And if I don't start Tor while I'm there, then I'm missing, but someone else might fill that in. So these are not necessarily the same 400 to 500,000 users. And this is totally crazy. So this graph shows the bridge users from all the countries in the world. And we see that there was 0 for a while. OK. And then we see in 2010 that there were just under like 80,000 or something. And then sometime in like 2011, we just had this huge spike. We actually have no idea what that came from, although there is some possibility that someone had been trying to run a botnet or something through this, and then they were like, maybe it's too slow, and then they stopped. It's actually unclear what happened, but it's good to know that for at least a moment, someone was doing something interesting there. I mean, that could have been an academic probing the network, right? Who knows? So now we're going to get to the graphs that are really worth talking about. So these red events here, these red dots, they show censorship events or potential censorship events. And these are predictive models that are layered on top of our normal graph. So in the case of users here in Egypt, anybody want to hazard a guess what this is? Just shout it out. Yeah, exactly, right? So this is the January 25th revolution in Egypt. There's about 500 users, right? Really that care about their privacy, and then all of a sudden they start to have a revolution, and boom, look at that, right? So they pass the word on, and all of a sudden a bunch of people involved in the revolution were like, oh man, I really care about privacy. I had no idea that I cared about privacy, but now that I know that means that I'm not going to get arrested for going to a protest, I really care about that. And then this right here is, of course, the famous pulling the plug on the internet, which is often referred to as the first pulling the plug on the internet, which it, of course, is not. But if we just pretend for a minute that it is, this is an important event. We also see some other events, some other censorship events, and then it goes back to normal. I'm really proud of that graph. I was working day and night during the January 25th revolution to help people get online and to talk with them about what was going on and to work with my friends in Cairo. I was in Egypt before and after the revolution, and I was actually there in a couple months later. And before and after the revolution, I mean the January 25th date. I was not actually there on the 25th, and the revolution, of course, is still ongoing. But I think this is fantastic because we were able to get the word out. And my hope is that some people were able to stay safe as a result. If we look at the United States, we see that there are quite a lot of users. So this is a 2011, 2012 graph. And there are times in which there's more than 100,000 or 150,000 users online, but generally it hovers at about 60,000 users at any given point in time. These events here clearly correlate to events that are happening in the United States in some way. I'm not exactly sure what they are. I'm actually more in touch with what was happening in Egypt. But this is one of my very, very favorite graphs. I wasn't sure that this talk was actually going to be a tour de force of just graphs that I love, but I thought graphs that I love was a better talk than graphs that I don't love. So in February 2011, you had basically no people in Syria using Tor. I mean, it's very small, 250 or something. And check that graph out. These events here, this is Blue Coat right here. That right there, that's Blue Coat. I know because I had some of their log files. And, it's like, gosh, what does oppression look like in the 21st century? It looks like that. It's an interesting microphone artifact. So this right here is actually totalitarianism on a graph, brought to you by Blue Coat. Lebanon, for example, has a really similar thing happening here, which is a smaller number of people, obviously, but it drops down, and we see this event happening here. It's not exactly clear why that happened. We didn't get a report from anyone, but half the Tor users in Lebanon just dropped offline. And it's totally unclear as to why that occurred. This, however, in Kazakhstan, over Theristan, as we like to say, this is actually a deep packet inspection, like automatic protocol classifier, and it just killed access to the Tor network. An interesting thing is that when this doesn't drop off to 0, it tells you a little bit about privilege. Who do you suppose has access to unfiltered internet in Kazakhstan? Right? Well, whoever that is, they need privacy too. But it's fascinating in that this is everybody, and this is everybody with privilege. And if we look at Jamaica, I don't usually think of that as a place with internet censorship. It's not really clear if this is what's going on here, but it's an interesting data point, which is that you have a huge spike in users, and then you have this kind of weird drop off there. Iceland has, I think I know every Tor user in Iceland. it's about 200 users every day or something like that. So to all of you that are using Tor in Iceland, you just made the graph go up here. This is a fantastic graph for a totally similar reason to Syria, which is if we look here and here and here, these are different states of the arms race. So for example, I think it was here that they decided that one of the parts of our TLS handshake was non-standard, and they filtered that single parameter in the TLS handshake, but it was a server-side parameter, so we sent out a patch, and boom, it worked again. And the same thing here, and this was another one of those events. And again, we issued a patch, and all the clients started working again. Because a lot of the distinguishers in TLS, where our TLS stack looks a little bit different, even though we use OpenSSL, we can fix them on the server side, all the servers in the network upgrade, and all of a sudden all the clients can connect again. So this is great, because it actually shows, they made a ding in our armor, so to speak, in that they blocked access. But at no point did they break the confidentiality or the authenticity or the anonymity. They just, in these cases, actually just blocked access. And we don't have machines in these countries doing these probes. We can see when people connect to us. This is a crazy graph in that, I think about the future of, different countries in the world, and I never thought that Ethiopia, for example, would be a place that would be implementing tons of crazy censorship. Now, it could be just that their network sucks really badly. And I think that that's entirely possible because lots of the internet is really broken these days. But in this case, it just seems highly implausible that it would almost drop off entirely to zero, although it did happen here. But so it's possible that Ethiopia right now is having a censorship event. And this is a great one because you'll notice in Germany, it is the case that there are no censorship events. So you can actually tell a lot about a country. In fact, I would posit you can tell a lot about whether or not a country could be considered free or not by a bunch of different metrics. But the metric that I like to use is looking at their internet. It's like if they freely allow you to use the internet, censorship is, I like to say, is a second order effect of surveillance. So this doesn't mean that Germany's internet is free. It just means that maybe it's free from tampering on a wide scale. I mean, as I understand it, the police, like the BND and the BKA or BSA or whatever they're called these days, but all these different organizations, they have the ability to do man-in-the-middle attacks on all the telecom DSL lines. So when they want to target someone to break into someone's computer, they can do that. That's not going to show up on a graph like this. So it doesn't mean that the country is free necessarily, but it is fascinating to note that at least here on a wide scale, you don't see wide-scale information control and suppression at the network level, whereas you very clearly see that here. So this is at least one way we can think about countries and whether or not they're free. It's also, I think, from a trade perspective, kind of interesting. Same with Bangladesh. China is a really sad story in that you can pretty much see Cisco screwing us over and over and over and over and over again. And really that's Cisco screwing the Chinese people in pursuit of profit, right? So if there are any Cisco people here, kill yourself. Right? So, yeah, that's good. I really appreciate the 3 people that don't work for Cisco clapping. The bridge users from Syria also, this is fascinating. So it's 0 here. Revolution starts. We go to over 10,000, right? So we're talking tens of thousands of people in Syria are using Tor to stay safe because they understand the data retention issues, they understand the censorship issues, they understand that serious harm can come to them. And the same thing is true for Iran. And these events directly correlate to the other censorship events that are taking place for the large-scale network. This is actually how you can see if bridges and relays are blocked at the same time, is those dips. That's where it's a protocol classification, not an IP address discovery issue. Not 100%, but usually it is the case that if we look at those 2 graphs and we lay them on top of each other, we in fact see that the bridge users are being blocked by protocol classification, which gives us some idea about how to debug this and to fix it. And bridge users in China is on the upswing again. It was the case that we had lots and lots of people using Tor in China, and it just keeps getting worse there. Basically, it's like networked authoritarianism to the extreme. So with that said, I've got 3 slides left. I want to introduce an idea to you guys, which is, I think, a really important one, which is I've been talking about this in the framework of human rights. So we are working at the Tor project not just on building an anonymity system, but we're actually working on building a human rights observation system, where the basic idea is that Access to information is a basic human right. The ability to speak freely is a basic human right. So we are building a project which we call OONI, or the Open Observatory of Network Interference. Sorry for reading my slide. And the idea is that we look at networks and we give away free software that produces open data. We have open methodologies that are peer-reviewed, and then we can actually look at that data and draw conclusions. So political scientists don't have to pretend to be computer scientists anymore. And it means that we'll actually have the ability to debug these things. So for example, this tool will be able to collect packet captures, it will be able to do all kinds of stuff, and then submit it to a very large system online, which anyone will be able to download the data. And they'll be able to say, why doesn't my network work in China? Well, I'm going to go to the Uniprobe data repository. I'm going to look up all my IP blocks. I'm going to see when people have tried to reach it. And I'm going to look at that data, and I'm going to analyze it without having to have anybody in the country. But if there is no data there, and I have a user there, they can install this free software, run this, and they're good to go. They'll have that data. And we're trying to build it on the basic scientific method. So the idea is that we're going to have controls, and we're going to be able to do dynamic checking of a network to see if there's tampering. And we have some really cool techniques that allow us to actually say the 5th hop in the network is doing a man-in-the-middle attack on port 80. And it's a blue coat device. And that's really great because it means that when someone breaks a sanction, we have the evidence to bring it in front of some kind of independent judiciary and to hand them their ass, as we say in the United States. And that's really important because that will impact their bottom line, because when they assist in genocide, just like someone selling machetes in Rwanda, they should be held responsible. And this helps to create transparency where people use their privilege in the pursuit of profit in a way that actually harms humanity as a whole. So this is a human rights observation system, if you will, which is a little bit strange to think about it in those terms. We also have a whole bunch of public research on the anonymity bibliography, and the Free and Open Communication Online conference, which is part of Usenix. It's co-located with Usenix this year. It's a place where if you're working on these kinds of issues, I would highly encourage you to submit papers to it. So if you're debugging really crazy deep packet inspection that is screwing with the services that you offer to people, it would be really fantastic to know what's going on, right? Because we have to talk about censorship and surveillance in order to push back on it. Because even though it is, in some cases, arguably beneficial to do this kind of surveillance and to have this kind of censorship, realistically, it's also a serious problem. And in fact, any time that those things are possible, it's because the underlying protocols that we're using are insecure. And we should fix those so that we can actually keep, let's say bad people out, right? So the canonical example I'd like to give is for the FBI to be able to do interception, in theory to catch really bad criminals, you have this hilarious problem, which is that every person in the United States has to remain vulnerable to man-in-the-middle attacks on their cell phones, to man-in-the-middle attacks on their web browsing, to DNS spoofing, because for them to maintain that privilege in secret, they keep everybody else vulnerable. And they pretend that the law means that people won't do these things, and only they will be able to do it. But the irony here is that that's not the way that it works. And when they build in backdoors in addition to it, they actually create a system by which they collect this information, and they will not necessarily have control over it. And that's not a particularly convincing argument against the FBI, but it's an interesting problem where their job in law enforcement and intelligence gathering comes into direct conflict, right? On the one hand, they're supposed to spy on people in order to gather intelligence, and on the other hand, they're supposed to keep people safe. But in order to spy, they keep you not safe, which is hilarious, but also incredibly depressing, because even though there are some good people there that are working on this, the techniques that they have are, in a lot of cases, quite dangerous. And in fact, right now in the United States, they're working on a thing which is CALIA 2. Any of you heard about this, CALIA 2? Oh, okay, so anybody heard of CALIA 1? Yeah, okay. So CALIA 2 is basically backdoors, key escrow, all the same stuff, hand over the plain text, log a lot of data, and they are generally asserting that people do not have the right to speak about getting legal requests. So people are talking about moving to the cloud. If you move to the cloud in the United States, the government asserts that it can send an administrative subpoena to the company and get the data. They may not have the right to stand up in court and to fight it. And you don't have the right to know that it's happening to your data because you weren't served with it, and you have no expectation of privacy when your data is in the cloud, because you willingly gave it away to a third party. Right, so that's crazy, but that's also what's actually happening. And I've actually been subject to this with regard to Twitter and to Google and some other stuff. So some of my accounts I read in the Wall Street Journal were actually targeted with these legal methods in order to read my email. So it sounds like a faraway thing, but this is this dichotomy that's set up there is pretty scary. Anyway, we have a whole bunch of free software that helps to implement either censorship detection or distribution of software when there's censorship, and of course the anonymity system as a whole. And yeah, so if you want to help out, we would love to hack on free software with you. And if you want to run a bridge or a Tor relay, we could use the bandwidth, because mutual aid and solidarity are part of the way that we are helping to create sustainable change where every person has the right to speak freely and the right to read without exception, not one human excluded. So if there are any questions, I'd be happy to take them now.
Time is pushing on, but I'm sure we have time for one or two questions. I see one here, Klaas. Can we get a microphone? Oh, the microphone's over here, so we'll start with Kate.
Okay, you gave an ethical reason why you are doing this, by chopping up people in Syria which you where you want to protect them. However, I have a very minor ethical issue I want also to bring up, and that is child pornography.
Oh,
where,
I'm glad someone did it.
Just in the Netherlands, a big case was done, and the amount of damage people do to these children is not even minor, to say the least. So, but they use heavily your network. So how do you look at that? And I have a follow-up question is, if you, so do the legal, does the legal responsibility of what goes on in the public network not transfer to the exit nodes, so that if I would run a relay and a lot of this stuff would exit via my node but not known by me, I would still be responsible?
Okay, so I'll answer your follow-up question first, which is that depending on the country that you're in, you have a different legal answer. And I'm not a lawyer, and I'm certainly not your lawyer. I don't even know which country you're from, so I'm not going to give you legal advice. But I can say that when you run a Tor node in the United States, and in much of Europe, for example, in Germany, it is true that if the police decide that your Tor node is interesting, that they might come and talk to you about it. And they might even arrest you in the middle of the night. That's not happened to my knowledge in the United States. That has happened to a couple of people in Germany. However, the liability depends on the law. So in the United States, for example, I regularly receive DMCA takedown notices, or actually I haven't in a while, but when I was receiving them, I had a standard form letter I replied, which is, I run this network. It's an overlay network. The DMCA, the Digital Millennium Copyright Act, exempts me specifically from liability as a network operator, and this is part of a network. I don't even have any logs whatsoever. I'm really sorry to not be able to help you, but I literally cannot help you because the system is designed to not keep the information that you seek. So that depends on the country, but that has ended every conversation I've ever had. I've been contacted by like the Spanish secret police, the Germans, the French, the Americans. Same story every time. They're like, okay, dead end. And it just so happens that a lot of people who actually hunt child pornographers use, and this is to answer your first question, they use the Tor network. Because if the FBI goes to a child pornographer's website and they download child porn so they can collect the evidence to prosecute that crime, they look like a Tor user, because looking like an FBI agent is actually not good. In this case, I think it's the Internet Watch Foundation that sometimes uses Tor. These are the people that build the child porn list, essentially, saying these are the URLs that have child pornography. So you have this hilarious problem, which is that if there are people that are doing that, you don't know whether or not they're the police hunting down a criminal or not. And that's actually good, because it means the police can hunt down those criminals. where previously they may not have had the ability to do so easily. And that's, I think, one of the most important things, which is it's an equalization. Because the problem with child pornography is not that people can download it, it's that people are raping children, right? That's the problem. So what Tor does is it allows everybody to be able to speak freely and not just criminals. So everybody in this room gets privacy by design. Everybody in this room gets anonymity and the ability to resist censorship. That includes bad people, but bad people already have tons of ways to do that to begin with, and good people have almost no way to do that. And so this gives good people of all stripes the ability to do something about it. And in the case of child pornography, I think it's really worth addressing this, because a lot of people would punt on it. But you either believe in free speech for everybody or you don't believe in it, frankly. And it's a thing where when you want to take it away from some people, it will be taken away from all people at various points in time. And one of the most important things that happens here is that people give themselves enough rope to hang themselves. And this gives you the ability to collect evidence to actually stop people from raping children, because they've published that information. And now you have pictures of people who are victims that you can track down, that provide evidence, for example, for the police to be able to find these people, and to find the victims, and to help them. It is not the case that when the internet was invented, child pornography was created, right? The same problem existed with Polaroid cameras, and in fact, long before cameras, and long before the internet. But this gives us the ability to have privacy and anonymity that we have never had before. And it shows us that there is a really serious problem in society as a whole. And we have to address that problem and not just attack the symptoms, because it seems like an easy thing to do, because it's not actually effective to attack the symptoms. We have to attack the real cause, and that is, frankly, harming children.
So time is pushing on. I think we have one final question.
Sure. You're going to ask about terrorism?
No, far from it.
Oh, great.
Klaas Wierega, Cisco.
I'm sorry. What?
Actually, Kees asked pretty much what I also wanted to bring up, but still I'm not really satisfied with your answer. By the way, thanks for pointing out how sophisticated our deep packet inspection stuff is, etc.
Well,
but no,
I got it. I'm sorry, I'm a little tired. You work for the fascist organization known as Cisco.
Exactly.
Yeah, okay, great, right on. Okay.
But you say there was child pornography in the era of Polaroid, and sure, but we have new tools that allowed for distribution of that kind of stuff on an unprecedented scale, the internet, and we are happy with that. And the internet is used for many good things and also for some bad things. Mm-hmm. What I think in your response to Kees's question, I think it would be fair to say that you are also an arms dealer, and you're rightfully proud on the fact that your software is used in the Egyptian revolution, etc. At the same time, you are also supporting abuse and bad things happening over your network. And
can I ask,
to be honest, I think it's a fair...
I want to just interrupt there. What do you think of Gutenberg? Would you say that he was a pornography producer because he enabled people to create books about pornography?
He enabled the distribution of pornography, sure.
Okay, all right.
Yeah.
I just want to clarify that. All right. Well, so
you disagree?
No, I agree absolutely. Yeah, Gutenberg. You know, the Bible is very pornographic, and I think it's important to acknowledge that absolutely. So the thing that is important, I think, to respond to that, we're not arms dealers. I'm sorry to say it. Because giving away information to all people freely and not charging for it, literally not charging for it, it's free to use, it's free to get the spec and all that stuff, that's significantly different than selling specific pieces of hardware to hunt down the Falun Gong and to kill them in a genocide. There's a huge difference there. And if you don't see the difference, I would encourage you to consider what it would be like if you were that Falun Gong person. The thing is that at some point you will be that Falun Gong person. And that's, to me, is something that is very scary. There is a difference between that and building an anonymity system where all people have access for free, to be able to read freely, to be able to speak freely. And it is true that there's an unprecedented scale. And just like Gutenberg, it's unprecedented in an equal way that is, I think, a liberation technology, if you will. I'm happy that people in Egypt used it because it's a non-violent, direct action that allows people to protect themselves. Like if you invented penicillin, for example, it's true that terrorists can heal themselves with penicillin. But I think we would generally all agree that it is better for humanity to know about how to cure disease than not to cure disease. And it is true that bad people will always be able to do bad stuff. But the question is, will good people be able to do good things? And is the intention for good people and regular people to be able to do that? With Cisco, what we find is that they don't give a shit about that. They literally have a slide from, I don't know if you've seen this, but it specifically says, help hunt down or locate unwanted religious minorities as a selling point in China for the Falun Gong. This is a thing that was selling. There's a huge difference between that and what we're doing at the Tor project. And I think that, well, it's interesting to create that sort of straw man argument and try to say that I'm in the same camp as you. It's not. You know, IBM and the Holocaust, same thing, right? They're neutral punch card machines, but Thomas Watson knew that the Nazis were using them for genocide. And there is some culpability for companies that do that. Sorry to say it, Cisco's in that camp, right? In 50 years, it's the same deal.
I was not denying that, and I will stop it at that before the chair interrupts me. But that was not what I was saying. I'm not saying it is in the same camp. I'm not condoning those kind of things happening. Let me start with saying that it's a big company. I don't agree with everything that happens. Just like I don't agree with many things that are happening in other places. I'm just pointing out that it is not a black and white thing. Powerful tools can be used for many good things, but also for bad things. And I think that is a worthwhile statement to make.
Yeah, so just to clarify, I totally agree with that. I also think the important thing here is that the good outweighs the bad. Right? It is a neutral technology in the sense that everyone has anonymity, but it is not neutral in one important way, which is that everybody in this room has privacy and anonymity and the ability to resist censorship in a way where previously the power dichotomy was flipped. There's an asymmetric power relationship, and now it's the other way. And so, for example, if you can't target someone for exploitation anymore, you're in a totally different camp. You're reduced to a different way of behaving. And that isn't equal, but it is not equal in the sense that it empowers every person on the planet to have that, which is very, very different, I think, in a positive sense, from some of the things we've seen in the past with technology. Because the technology that wires us all together very well may be, for some people, the thing that strings a bunch of us up. So we need to make sure that when we connect these things, we don't create machines which are basically building the largest database of a particular racial minority and then hunting them down. And a way to do that is to actually make sure that it's equally accessible, it's open, and it's actually secure.
So I think at that point, that's a very good point to draw this discussion to a conclusion. I'm sure the discussion can continue in the hallway. So let's thank Jake Appelbaum again.
Thanks again.
And then, before I let you go for coffee, I mean, on the scale of the issues we've just been discussing, this is far more mundane, but I do have a number of announcements I need to quickly share with you. Tonight, as you will be aware, is the gala dinner. It starts at 8 in the Harper.